Morning everyone. So as Bonamc has mentioned, my name is Caine Wanjau. I work at Twiga Foods as the CTO, and as you can tell from the banners and the posters here, we sell bananas. So our business has actually been about selling fresh fruit and vegetables, but today we're not really going to talk about bananas. It's more really around how technology helps us sell bananas. So I'm hoping by the end of this you link what we do and what the tech team is able to, how the tech team is able to enable that process. So quick brief background about Twiga. It's now about four years old. We're basically a mobile-based supply chain for Kenya retail outlets, kiosks, and market stalls. We deliver fruits, vegetables, and we're now starting to do FMCGs to vendors every day of the week. We've now been able to reach about 5,500 vendors, and over the last 4 years we've been able to scale and cover Greater Nairobi. So that's Nairobi and the surrounding counties, Machakos, Kiambu, and Kajiado, and that's the area we supply to. Our customer, our typical customer, is your mama mboga or street vendor, because 96% of food is sold through those channels. So that's what we've managed to distribute to up to today. So a quick history about our evolution. When I joined just under 3 years ago, we were about 45 employees. 1 year later, we were doubled to 90 employees. Around this time last year, we were 150. And right now we're over 350 employees. So we've managed to really grow quite well in the last 4 years. And just looking at this in a bit more deeper detail, we have about 6 core business units. We have operations, which is our biggest. So there you have sourcing. We have the pack house, which processes the goods we buy. You have logistics, who manage the distribution, both inbound and outbound. And you have the sales team themselves. Other than operations, we have HR, admin, finance. We do have design thinking. It's an area we decided to invest in heavily as a company. And we also have the technology department on our side. So looking specifically at the tech team, when I joined, there was no tech team. So I essentially joined as the founding CTO. About 1 year later, we had grown to 6. Last year, this time, we were about 7 employees. And since then, we've almost quadrupled. The tech team is now about 25, supporting the 350 employees. So the tech team is about 7 or so % of the workforce. And that's really the focus of what I want to talk about today, what the tech team has done. So some of the products and projects we've worked on. First one is called DMS. So DMS is basically, it stands for Data Management System. So this is an app used internally by staff across the business. So the 6 units I went through, ops, HR, admin, finance, design thinking, and tech, all use some aspect of DMS in their day-to-day. A lot of things we've been working on is dashboards and reports. So DMS is primarily used as a data collection or data capture tool. All this is then translated to dashboards and reports. And then another big part of the work we do is integrations, because we have a lot of systems talking to each other. So just to pick a couple of examples, we have our DMS talking to our ERP. So we always do all our sales reconciliation on the fly. Right now we are fully digital in terms of paying farmers. So anytime we buy, we log that onto a platform. That's now been fully integrated with mobile money, and then that sends out money to farmers on an automated basis every single day. Other integrations we have is the systems that we have internally talking to each other. We've automated things like payroll. So a lot of our systems actually talk to each other to kind of reduce our workload internally in the business. So there's a team dedicated to that. And then IT support. And this is both technical and non-technical. So given that we are 350 employees. I'd say about 200 or so of them use our technology products, and beyond just supporting them with the software, we need to support them with the assets and facilitating them on the ground to do their job. So we have an infrastructure support team, and given we're distributed all over the country based on where we source, we normally need to manage assets all over the country. It may seem trivial, but it's actually quite a big job in and of itself. So we do have both hardware and asset IT support, and then the IT support from the software built, which I'll delve into in a bit more detail as I go on with my presentation. So with that in mind, that sets the context for my topic, which is when, why, and how did we scale? What have we learned? What are the decisions we've made? What are the things we've seen? The idea here is to share the experience we've gone through as Twiga, so that even as an engineer, as you ideally want to join a fast-growing, scaling organization. So the idea is, what lessons can you share so that you can also have an idea of what it took? Also the learnings, there have been lots of learnings on our side. So just share those and help you guys also understand what are the challenges one can face in this process. So I'll think of it in 4 distinct phases. I'd call phase 1 the initial team. So as I mentioned, when I joined, there was no technology function within the business. At that point, we had actually figured out how to buy and sell bananas. So the business was figured out from a unit economics perspective. But it's now a question of, if you're going to introduce technology, what is it going to do, and what is the team needed to do what the tech needs to do? So the first decision I faced was around hiring. So I was like, what do I need to hire? How many people do I need to hire? And how does this align with what the business is trying to do? And for me, the key lesson there was hire only what you need. And there's a big reason for this. Initially, when you're building, the first thing you're building is building a minimum viable product. And in a fast-growing startup, especially one of us that is primarily an operation business and the technology supporting the operation, what you find is there are a lot of changes, not just in terms of what the business wants to do or want to sell or want to buy, but also in terms of how the business thinks about its processes. When you're 5 people, you don't think about the business the same way when you scale to 10, 20, 50. What I realize is anytime you add 20 more people, a process or something has to change, because it's just the nature of supporting a big or large growing organization. So with that in mind, it was around thinking, what kind of team can help us build product in this rapidly evolving scenario? What does an MVP look like? And the thing we really focused on was keeping it simple. I know as engineers, we tend to think around how complex or how cool or how flashy my app will look. But what you find is actually the best way to guarantee product stability is around simplicity. One reason for this we realized early on was when we were introducing technology for the first time, the thing you need to manage beyond just building, releasing, and training people on the product is the change management. As much as people feel manual is inefficient, there is a level of comfort one develops when they're used to a certain way of doing things. So for example, before we released our first tech product, everything was running on WhatsApp. Yeah. So the teams would go and sell. At the end of the day, they would book it in on WhatsApp, and everyone would use that to track how the business is doing. So when we introduced technology, just to de-risk it from a business perspective, we told the team, okay, for the next few weeks, use WhatsApp in parallel with the app, so that in case anything goes wrong, you don't use the records, given it's business critical information. And what we realized is, the one thing that kept coming back to us is, keep it as simple as WhatsApp, in the sense that I don't want to have to do more than I already know what to do. So when thinking around product, it's not really all the features or all the functionality you can build into the tool, especially when building a minimum viable product. Think of what you're replacing or what you're improving, and try align it with that as much as possible. So our mantra during the first phase of building product was keep it simple. The other thing we did was also decide to tackle it one problem at a time. if you looked through that business unit slide I had, you saw operations is divided into 4 distinct sections. So you have sourcing, you have the pack house, you have logistics, and you have sales. Now, there's always a temptation to dive in and try solve everything. It's just the engineer's mindset. If I have problems to solve, I want to tackle them and do them as quickly as possible. But what you realize is there are certain areas where you can have more impact much faster. So if you focus on one thing and execute it to the end, you'll actually find there will be more impact. And the other thing we noticed here is, as you solve one problem at a time, you actually get buy-in and stakeholders who are your champions within the organization. So provided you've built, managed, and released well, you'll find that the people who are now using the technology actually become your advocates, and the other people who actually need it now become champions and start asking, when can we get this product? So the issue I faced before, where you may face resistance because people are used to a certain way of doing things, starts turning really quickly, because what you quickly realize is, I have built something people want, and these people are my champions, so it's a matter of seeing, how do I use these guys to actually help me push the product I'm building. So by tackling one problem at a time, it helped us focus, helped us build it to the best of our ability, and through that, we're actually able to do the change management much, much better. The other thing which I would really emphasize for everyone to take as seriously as they can is fieldwork. And by fieldwork, I mean not sitting in your office and writing code. At the end of the day, you're building products for people to use. There's a consumer or there's a user at the end of the day. So what we did and what we still do to the extent that we can is, as soon as someone or an engineer joins the team, they actually spend some time of their first few weeks during induction going to the field. And it's not really about going and deciding a product decision. It's just understanding the context and the environment within which users are using your product, understand the familiarity or the comfort with using technology, because even amongst our employees, the ones we've given out devices and assets to, a lot of them are using smartphones for the first time. Now, you may sit in the office and build all the cool tools, all the interesting animations, or all the cool features that you want, but at the end of the day, you'll find it's the simplest things that can potentially trip you up. So if someone sees a home icon and they've never used a smartphone, they may even think that it means for them to go home. We've seen that happen. We've seen that happen before. So you really have to understand the context within which your user is interacting with the product you've built. So fieldwork is really, really important. I'd actually encourage engineers and developers, before you go and build product, spend time immersing in yourself. And this should never be thought of as a UX or design exercise where someone will go do a research exercise, do some fieldwork, and then bring your presentation, and then that's what to implement. If you've not immersed yourself in that context, you'll never get the full picture. So one thing I would encourage developers to really emphasize on is spending time and quality time doing fieldwork. The other thing we actually focused on during this stage was what I'd call lean processes. So one thing that always is, I wouldn't say a challenge, but devs spend a lot of time thinking is around what routines, what processes, what's the framework of me doing the work I'm going to do. So how complex should how complex should my repository be? Which branching strategy should I use? What should be my approval for process? What should be my pipeline or software deployment process? You don't want to get too caught up in this at this stage, because as I mentioned, your product is always evolving. And when you're building a minimum viable product, I would actually encourage you to have a minimum viable process. What I mean is, do just what you need to do to ensure code quality and push it out. Of course, with the right checks and balances. When we were a team of 6, we had, I remember actually the core engineers were 3. There was one Android engineer, and then we had a second Android engineer, and then we had a back-end engineer at that point in time. Now, if you introduce too many complex processes around code reviews, pull requests. Not that they shouldn't be there, but this could actually be done in a more efficient way. But if you try, systemize, and put a process to everything, what you realize is you spend such a huge time just conforming to process that you actually lose the efficiency you're trying to get by building out product and shipping quickly. So to the extent that you can make your process as lean as possible, you'll actually find that's what, at least in our case, we found that's what worked in the initial phase of building out product. So those are kind of the things we focused on in phase one. This, I would say this was from end of 2015 until around end of 2016. At that point, we started scaling, and even within the technical team, we started adding more people. And so the needs of the business changed, and at that point, we also decided to review what we do as a team. And so the next stage for us was really, where should we focus? Around focus. So as I mentioned, should I? It's back. Okay. Cool. We're good? All right. So the next stage was around where we wanted to focus as a tech team. So at that point, the tech team had grown. The product had been fully built out. And even the company had, I think, doubled or was about 2.5 times by the time we had finished building products for sourcing, logistics, distribution, and sales. Oops, sorry. I thought, are the slides back? Okay. Great. So the first thing we realized was there's a natural way information moves across our company. If you think around the buying and selling of a product, in our business or how it was structured, everything originated in sourcing, went through logistics, went to the pack house, through to distribution and sales. And what we realized is if we follow the data path, it'll actually help us understand what the business needs moving forward. So take the journey of a banana, for example. It's more around, I've gone and registered a farmer, I've bought from the farmer, I've paid the farmer. That produce has arrived at the pack house, it's processed and ripened at the pack house, and then it's distributed and then eventually sold. So what we realized is by building or structuring ourselves to actually work in the way the business is structured, implementation of products became much, much easier. Sometimes you join an organization or you work on a project and you'll be told, this is the greatest need in the company, which is fine, but then you also have to realize what are the interdependencies. Who provides information that feeds another business unit, or who produces information that someone else needs to consume. So in our case, the information sourcing produces is consumed by our pack house team, which is further on consumed by our logistics team, and eventually informs what we sell. So one decision we actually made and focused on was around following the data path. What you'll actually realize, it'll help with things like architecture decisions. So when you're building out your backend or your stack, if you try to understand how does information move, it actually helps you think logically around, this is what I need to store or design for on my system. This is who needs to feed in the information. This is how the information will be consumed either on a report or dashboard. And for us, that's one constant that's held true even up to today. By following the data path, it's actually helped us focus and make the right product and development decisions. The other thing here is the tools and clients of choice. And here I don't mean dev tools or software engineering tools. What I mean is user tools. So for a bit of context, Twiga has operations all over the country. We have teams going to the farm. We have teams selling all across Nairobi, and we have teams stationed at our central collection and processing centers. Now, when you think of tool of choice, the fastest way is always build once and deploy everywhere. And the best tool for that is usually either a web app or a PWA. But if you take a step back and understand what context are people using this in, you then start to have to decide, do I have to think around a more dedicated client build? And in this case, it's more around building dedicated apps for the team. The reason for this, of course, is because we're out in rural areas, connectivity is not always guaranteed. And as much as web apps nowadays store a lot of information offline, you don't want to be in a situation where, for some reason, it fails and then information can't be processed. Because we deal with business critical information, excuse me, because you deal with business critical information, what you realize is you really have zero or very little margin for error. So any farmer we harvest from or any farmer we buy produce from, we have to pay them within 24 hours. And because the whole process is digitized, us not capturing that record is actually not something we can have as a, I guess, as a fault point or failure point within our business operations. So we've actually engineered for reliability in this case, rather than for speed and flexibility. This decision is not always black and white. There will be always many factors that that one has to play with in terms of making this decision. But tools and clients of choice, depending on the context, we are building enterprise products that are used across our business. So the first thing we usually rely on is, the first thing we normally focus on is reliability, and then we can look at flexibility if we feel reliability is well guaranteed. And then another point there is what we call business and product interdependencies. So as I mentioned earlier, by generating information in sourcing, that informs what the pack house would use in terms of understanding what product has come in. So when we looked at this and tried to understand who needs who to do their job, what you find is you can actually use this to your advantage. If I'm in sourcing, I buy something and I pay the farmer, what you want to do is inform the rest of the business, this is what's come, this is what I need to do, and this is the information I need to action. So what we found is, by building the product in such a way that what one person does informs what another person needs, you actually find quicker adoption and take-up. So just back to the point I made earlier around focusing one problem at a time, we should think of this as some kind of Lego project, where if I put one Lego, the next Lego should just sit on top of it, and with time you have this complex structure that's many small parts working together, and you basically get to achieve the overall objective of stakeholder buy-in. So one area of focus for us really has been build this tool such that user one informs what user two needs, and you'll find they'll actually encourage each other to use the product as it should be used. The other thing we've really focused on is IT support, and the reason for this is very simple. You have to understand the problems your users have. You know, IT support tends to be outsourced. I think a lot of big companies have a call center that take calls. A lot of people think of this as something that should be not a focus area. But in our case, IT support has actually been very, very useful. One, engineers understand the problems the users are facing. Two, by actually solving the IT support issues yourself, you actually get to know where the pain points are, and it informs future updates. We've never thought of this as something that should be managed as a distinct function. So right now within Twiga, all the engineers on our team actually spend time doing IT support, and it's something we do in our scheduling and our sprint planning. More than anything, this has actually helped us be much, much closer to the users. And by us developing things like SLAs, response times, and resolution mechanisms, we've actually found that users tend to appreciate the effort that we put in solving their issues. So to all those engineers or all those building and scaling a team, always make sure you invest time and effort in building a robust IT support structure and system. The other area of focus has been on change management. This actually involves a lot of training and helping users integrate and adopt your system. So one thing we've invested in over the last few months is change management from a QA and training perspective. Anytime you go and launch a new product, we actually have a detailed and robust rollout and training and support plan. I know as engineers, we tend to think a good product doesn't need to be demoed or shown to users. But what you quickly realize is, if you're trying to drive a specific agenda, and this is technology adoption in the business, you want to minimize the friction between a user understanding what your product should do and using the product in the right way. So what we've really focused on is really investing in that function in the business, to the extent that we now have things like detailed 6-week rollouts across the country. So when we're launching a new version of our sourcing application, we had a team go and spend a week in each of our areas across the country just to understand how users will use this project. Of course, as time goes on, this can evolve. You can have, you can have things like videos, you can have manuals. Sorry, I'm battling a small flu. You can have videos and manuals, but ideally, when thinking of training, the first thing you always want to do is always understand what the users really want to achieve by using your product. What do you want them to do with your product, and build a robust training and management plan around it. So that's what we mean by when we refer to change management. The third phase was, I guess, trying to manage or predict evolving user needs. So anytime you scale, this will always result in more product requests. And it's not just a function of more people. So even if I have 10 salespeople today, if I have 100 in 1 year, they're still essentially doing the same thing. But you find beyond just scaling horizontally, you're also scaling vertically and adding new layers of management. So I recall when I joined, we had only 2 levels of sales management. We had the people selling and their manager, a single manager. But today as we speak, we have 4 levels of sales management. So we have the sales team that sell. They all report to an area sales manager. The area sales manager reports to a regional sales manager, and the regional sales manager now reports to the head of sales. Now, what you realize is it's not so much what you're collecting changes, it's how these people want to view the information that becomes, that evolves. So an area sales manager would want to say, okay, I just want to see how my routes are performing. A regional sales manager would say, okay, I just want to see how my areas are performing. The head of sales would say, I want an overall picture of how the business is performing. So it's basically the same data set, but evolving user needs in terms of how they want to consume the data. And this now goes back to a question of how am I thinking around the evolving product needs of my business, or the tool I'm building. If the product you're building is too inflexible to even take into account evolving business needs, you'll then find you quickly become stuck because you're always trying to make trade-offs. You start butchering your code, you start not following best practice. But if these are things that you think about actively during product development, it's something that really saves you in the long run. One thing we've also noticed is if you think through how the product evolves, it's always around what's the most flexible iteration of this product. What should it look like in 12 months? A lot of us tend to build for the here and now, but by focusing on where should this go, who need the product, what will they change? Of course, you can't predict everything, but if you focus on what the changing needs will be, you then find that you have less and less code changes to do, and you build up your technical debt much slower. The other thing is also, from an internal perspective, what kind of team should we have? So I know a lot of us talk about a full stack engineer. I tend to think of it more like a multi-stack. That's a term I just came up with. And the reason for that is, today you could be asked to build a dashboard, tomorrow you could be asked to build the app, the following day you could be asked to build a USSD implementation. And it's a question of, am I tooled and ready for this? I may find the best engineer for a certain part of the stack, which is good, which isn't bad. But the thing that's always playing in your mind is, what are the evolving business needs? Will the person I hire for a front-end role today be able to do a back-end task tomorrow? Or will they be able to do something around DevOps or security further down the road? Remember, as much as we have evolving user needs, we also have evolving technology needs. The bigger you grow, the more you have to maintain, the more you have to think of how the system is talking, internally to each of its specific components. So it's around also understanding, do I have the team to evolve with me to evolve with the company as it grows? And then tied to that, of course, is what I mentioned, flexible architecture and design choices. The thing around building product for businesses, at the end of the day, it still has to perform. You have no time to experiment or get data wrong or get information wrong, because especially when you're dealing with money, which is in our case paying farmers and receiving sales from vendors, we have to make sure the numbers tally up. And tied to these are things like operations, reconciliation, and making sure we're not having any losses in the value chain. The last thing you want as an engineer is for the business to tell you, I don't trust the number or I don't trust the data. So the whole basis of how you de-risk that process is by saying, okay, from an architecture and design choice, have I built this tool to withstand any business change? Right now, in the sourcing operation at least, we are probably in our 4th iteration in terms of how we manage the processes. But we're by and large still using the first version of the application. Now is when we've started the transition to the second version. One decision we made then that has really served us well is by thinking flexibly about the architecture and looking at it from a perspective of, regardless of what else changes in the business, what are the core things that will never change? And in this case, it's 3 things. Registering a farmer, recording the harvest, and paying them. Anything else can change, but as long as those 3 are accounted for, your business or your product should be able to survive any business change. So evolving business use and technology needs a tech team to think around flexible architecture and design choices up until the point you feel which you need to do a re-engineering effort. Of course, tied to this is optimizing for scale. So as a business grows, there'll be more use of your technology, and it's a question of, have I made the right architecture and design choices as the company grows? When I joined, we had 5 routes tied to 1 depot, and I think we had about 150 to 200 customers. Right now we have about 97 routes. We serve 5,500 vendors a week, and it's by and large still the same stack. So it was a question of understanding, okay, if the business scales to this level, will the systems we've built be able to evolve and still work well at such a scale? I'll probably even say you can even make trade-offs. So initially we had a monolith stack, and it still is to a large extent. But then as we scaled, we now started thinking around things like caching, things like indexing, all these things that usually make your system more performant. You could invest in them in the beginning, not that you shouldn't, but it's also around thinking, do I really need to make this investment or technical decision right now? You could, yes, but you could also argue that if I don't, it'll help me release product faster. And as you scale and grow, I'll then make the right product and technical decisions. One way to optimize for scale that's worked in our favor is investing in monitoring. So by making those trade-offs, you also need to know how the trade-offs I've made working for me. Now, the best way to do this is saying, okay, if these are the decisions I've made, I need to monitor some KPIs. So this could be things like average response time, throughput in the system. Am I analyzing the errors that are coming in the system? Because this is what's going to help you understand, this is a point at which I need to optimize for scale. So by investing in monitoring, it actually helps you know, okay, this is a point at which I need to start thinking around making these decisions around the system performance. Because from the KPIs or the monitoring tools, the information it's giving me, I'm getting to a point where we're about to hit a technical wall. So monitoring will actually be your friend as you think around when or why should I optimize for scale. And that brings me to our 4th phase, which is re-engineering. So that's really the phase we're in now as a business. So now that we built out version 1 and that's run across the business, we're now building out what we call DMS version 2. There are a number of reasons for this, but I'll just highlight the key ones. For us, it's because we're at a point where we've grown to 350 people. A company of that size actually is usually much more stable process-wise. We figured out what works, we figured out what what doesn't work, and at that point you're like, because we are now stable process-wise, I can actually start investing in much more long-term technical decision. But really the guide of this, regardless of the size of companies, are we stable? There's some things that will never change regardless of size. Something like buying a ticket is just a function of scale, for example. Something like building a payment service, that's just a function of scale. You could add features, but process-wise, you'll always know how that works from the beginning out. So we're at a point where we feel like we can make that investment. The second thing tied to this is the technical architecture choices. For us, we're at a point where, like, because we're building everything from the ground up, let's make the investment that will see us 3-5 years out down the line. And as a company, we've decided to invest in microservice-based architecture. It's, to be honest, it's not been easy. A lot of people in the team are doing this for the first time. So there's a lot of learnings. And whenever we're building microservices, we'll always have to appreciate there's an investment to be made in terms of building your base infrastructure to enable you scale microservices as the features and the company grows. So because we're at a point where we felt the first issue has been solved, we can actually make that investment in microservices. The initial build will definitely take longer than spinning up something and running it quickly, but you find where you're building, where there are many business changes, all at different speeds. So, for example, you could have your sourcing team requesting for product changes faster than your sales team. You don't want to spend a time as an engineer doing a lot of what-if debates, meaning, if I change this in sourcing, how will it affect sales? If I change this in logistics, what happens to pack house? What will I break? What will I not break? It's always about being comfortable in the decision you make, and by investing in a microservices-based architecture, an engineer or a team working on something can always rest in comfort knowing what I build will not affect the rest of the stack. Given the size of the team we are now, which is 25, one team could be working at a different speed from another team, and you never want it to be a point where you're getting to merges and a lot is failing because there are so many conflicts. So the technical architecture choices we've made have kind of helped de-risk that process. The other thing we've done, now that we're a much bigger team, is build multiple products in parallel. So what we've realized is, because we're at a point where we can support many business functions at once, you can have teams dedicated to actually focusing on a specific business unit. So within sourcing, you have a team building products for the sourcing organization. Within sales, that's the same. Within logistics and the pack house, you can have a team actually managing things for them independently. By looking at the first 2 points there, which is around stable processes and the technical decisions we've made, this becomes a much, much easy decision, and that's what we're doing in our re-engineering phase. The other thing there is team structure. So with team structure, what is interesting is, as you start, when you're the first few engineers, you tend to know everything that happens within the code base or within the technical function of the company. I remember when I joined, I used to know what has been committed. I used to know who has a phone, who has a password, who doesn't have a SIM card, who has a laptop. But as you scale, you realize you have to have a structure that can enable also the technical engineering function in the business scale. So the way we structured ourselves is, after the point we got to about 15 or so engineers, and we split them into teams. Within every team, I guess, we have a team lead and the engineers below them. And equally as important is the same structures you do for your engineering side of things, you need to have a similar structure for the non-engineering side of things. So if I think of our 3 core engineering groups, which is sourcing, sales, and integrations and infrastructure, we have equal team leads on the non-engineering side. So this is QA and training, IT asset support, and design. So by just making sure you have the right structure, you're actually able now to manage everything in a much more calm way. Tied to this is process, which is the last point there. The way to manage things when you're 5 or 10 engineers is very different from where you manage when you're 25 engineers. At this point, you need to start thinking around KPIs, processes. We've really invested a lot in that. Right now, we're strictly agile, where we're running very precise, concise sprints every 2 weeks. And even we've managed to get to a point where the non-engineering teams are running in sprints. So you have a sprint for the design team, you have a sprint for the IT asset team, and you have a sprint for the QA team. And it's not so much that they need a sprint. They could actually work without a sprint, but you want to have a uniform process across, just to make sure that you're always managing or KPIing the same thing. For different organizations, this would be different. But the key thing here is whatever process works for you, make sure it's uniform, make sure it's auditable, and also make sure it's measurable. Those are the three key things we've seen during this engineering phase that's really helped us. So as a last point, I'd like to focus on what our takeaways and learnings through these 4 phases we've gone through. First thing, no process is permanent. When you start, you always have this idea of what works, but you quickly realize a lot of things you think work do not work. Never be embedded or bedded to a process. What I've seen time and time again is a process should be discarded as quickly as you realize it's not working for you, and agreeing to discard it is actually not a bad thing. A lot of time we tend to think because we've invested so much in a process, we need to stay with it and stick with it through the end. If it's not working, feel happy to discard it. No process is permanent. Change is the only constant. And this is across all spheres. What we build, why we build it, why you have team members, why they join, why they leave. Change will always be there, and you need to plan for change. So as you build anything, the thing to always keep in mind is what I've decided to do today could be very different 3 months down the road. Sometimes you build product and you have to discard it for various reasons. Could be technical, could be business, could be product reasons. But for what it's worth, always be prepared to throw away the work you've done, because change is the only constant. Provided it's being done for the right reasons, never hesitate to change. The third thing is managing process change versus company growth versus product evolution. A lot of the things I've talked about are around what are the things you've noticed as the company has grown. Your process is always changing. The company is growing as well. And the question here is, how is my product evolving with a growing company? Are we making the right decisions for now, for 6 months down the road, for 12 months down the road? What you always want to work on is what we call first principle basis. Invest a lot in what you know will never change. For example, if you need to pay a farmer, you'll always need to pay a farmer. So you can make a heavy technical investment for growth and scalability. If you're making a client-facing application, so saying this is who's going to use it, that's more likely to change. The role could change, the responsibilities could change, the system could change. So it's about understanding, okay, can I build it in such a way that it's flexible? And a lot of this goes to what I talked about here, which is around going to the field and understanding what's happening and what's likely to evolve. One thing we've done on our side is the tools or the app and the dashboard we've built is very permission focused. So if today you had 2 distinct roles and the business gave you a 3rd role, which is supported on the application, we can actually go and evolve and quickly give you access to the other functionality you need. So it's also about understanding how am I building this thing to survive process change and company growth. The next thing there is size versus process. As I mentioned, now that we've grown to about 25, we have a more distinct structure within the engineering team. So initially, I said you need to focus on lean processes, but that only works up to a point. The bigger you grow, the more you need process. And it's not process for the sake of process. It's more around saying, how do I make sure that the people I'm working with or the people in my team have the tools or a way, for example, to give feedback? Is there mechanisms for that? Is there mechanisms for anyone to go and evaluate what's happening? Because remember, you can't be everywhere at the same time. So it's about understanding what process matters at what size. And that will always keep evolving. As I said, no process is permanent. This also goes to internal processes. So this is something you should always just keep in mind. The more I scale, the more processes will and should change. The next thing there is flexibility versus structure. When building product, we're always tempted to make changes on the fly, which sometimes is not a bad thing. But remember, when you get to a point where you're supporting 200 people using your product, and this is a business enterprise product for all intents and purposes, any change can have massive impact. So you always need to do an impact assessment before just going and changing something. Anytime you're releasing a new product, is there a rollout plan? Is there a product plan? As important, is there a communication plan? Because you're changing and you don't want to surprise people one morning that, hey, here's a new version of the app. If people are not pre-programmed to know this is what to expect, you'll find that you're going to spend a lot more time on IT support than you actually need, because the process and the flexibility you had when releasing for a few people is no longer there. So it's around building things like structures around such things, product releases, product planning, engaging with other stakeholders. So for example, like a lot of our team leads, they probably spend maybe 50% of their time doing engineering work. The other 50% of the time, they're engaging stakeholders and just making sure they're in the loop around what you're doing and using that opportunity to get feedback as well. The other thing is strategy versus detail. As an engineer, it's natural for us to want to make every product or technical decision, which isn't a bad thing. But as you grow, you have to also learn to let go. I think a lot of people have spoken about this. The way I think of this is, if you want your team to grow, you want your team to learn, or you want your team to take more responsibility, you have to let them make the right technical decisions. So if you make the right strategy decisions, then as someone who doesn't oversee the code base day to day, you're actually able to get a sense of what's happening. So it's around what's a strategy for me evaluating what's done. So in our case, for example, every 2 weeks at the end of a sprint, we have demo days where people come and present what they've done, and use this opportunity to also now discuss product and strategy decisions. Of course, during the sprint, the team leads manage the detail, but the more your team grows or the more your responsibilities change, you want to focus to shifting. You want to change to focus more on strategy rather than detail. The last thing around this is build versus buy. Now, the decision to build or buy software is normally a very personal decision. It comes down to what you feel you can do as an engineer. But then with time, you realize it's also around what's best for the team and what's best for the business. If there's a program out there that can do 80% of what you want to do, it's around thinking, how do I solve the 20%? A lot of us are always inclined to build. I know of engineers who've built 20 products for their company, but the issue is if you can't invest in also maintaining and supporting it, is it worth making that investment? And then it's a question of asking, by buying, do I get those benefits? Do I get the support? Do I get product evolution? For me, it's always come down to, if it's something core to our business that gives us a business advantage, especially for us in our operations department, that we can build because of the unique nature of our business. But if it's things that are out there, things like, for example, payroll, things like financial systems, those you can buy. The only thing I usually say here is make sure what you're buying, you can integrate to it. Because a lot of great softwares don't have integration capabilities. So if you have this hybrid strategy where you're building, just make sure what you can integrate into what you're buying. The other reason for me buying is I really want to see how, as startups, we can support the local ecosystem. So to the extent that someone local has built something we can buy and use, I usually encourage that, and I usually try to advocate for that. A lot of the softwares we use internally have actually been built and maintained by local developers. So those are the two reasons really for us wanting to buy. So with that, I've come to the end of my presentation. Thank you for listening. If there are any questions, I think we have a short Q&A session. Asanteni.
So we'll have a roving mic and just have maybe 1 or 2 questions. I see there's, just raise your hand if you want to ask a question. I see there's one over here. And keep it short.
Thank you very much, Caine, for that excellent presentation. My name is Wilfred. I'm a local software developer. I noticed that you have 25 people in your technical team. Yeah. I'm just curious to know, out of those 25, are they all developers, or do you have people with other skill sets like project managers and other areas that are relevant to software development?
So that's a good question. Of the 25, I think roughly 15 are core engineers, and then the 10 are what I would call non-engineers, but they still play a critical function. So we have, just thinking around the units within tech, we have team leads that lead teams that work on the product for sourcing, the product for sales, and we also have an integrations and infrastructure team. So those have team leads. Then we have 3 other team leads that do non-engineering functions. So we have training and QA, we have design, and then we have IT support more from an asset and physical infrastructure perspective. So the reason that is important is at some point, it's never just about software, but it's organization around supporting what you've built. Remember, I talked about training people, issuing them phones, replacing phones, designing the design work that goes into all our products, including the banners you see here. So what you realize is, if you don't invest in the non-engineering function of your business, you'll actually get to a point where you're actually risking a lot of things, because good product needs great support. Those two go hand in hand. It's just a way a lot of us, when we use, take the example of M-Pesa. Well, a lot of us use M-Pesa and we don't think much about it. But if a transaction fails or something goes wrong, a lot of us get comfort for the fact we can call a number, or there are tools or ways for us to get the support you need. So I would encourage engineers, never just look at the engineering function itself. Also take time to think of the non-engineering aspects and what it will take to give your users a comfortable user or product experience. Yeah.
One last question. Yes.
Okay, thank you very much for the presentation and sharing your story. My question is, do you have a preference for a particular technology, let's say programming language, or maybe you prefer a mix, maybe as different aspect, maybe for different technology, or do you have a preference, or it's a mix of different technologies? Thank you.
My mantra has always been, look for the best tool for the context and the purpose. So just thinking through where we've gotten to where we are today, initially, even when I was doing the initial recruiting, I wanted to have a good understanding of what's happening under the hood. And in my engineering life, I've been a Python and PHP developer. So I hired with people who have those skills, not because I wanted to actively manage what they're doing day to day, but because I knew, especially for version 1, you need to have good oversight of how the product is working. Not so much from a technical perspective, but you want to understand the business logic of what's going on under the hood. So initially, the backend was Python, still is, to a large extent. We built an API for that, and then we had an Android client and reports that were now consuming that information. However, as we evolved, when we go to now what we call the re-engineering phase, because we're moving to microservices-based architecture, you can actually be stack agnostic, if I can call it that. The reason being is you want to find the best tool for the purpose. So if you're building SSD, yeah, you probably want to use Java rather than Python, because it works better in that kind of context. There are all these new programming languages that give you a certain specific technical advantage, whether it's capacity, the number of concurrent requests, that kind of thing. You'd always want to start evolving and thinking, okay, what's the best tool for the job? So right now, we have about 3 or 4 languages in our stack. Now that we've shifted to microservices, we still have Python, we do have Java, we have Go as well on our stack. And then of course Java is used on the front end, and JavaScript for the dashboards and the portal. So you always want to be flexible. I guess you want to make the right decision at the right time, and for a growing company, that's something that always evolves. Initially, I just built for the purpose of, I want myself and the team to understand the context, and you really don't want to take any risks at that point. It's not the experimentation phase. Now that we're doing microservices, we can invest a bit of research, experimentation, but that's because you already have a base to build off of. So I guess the answer is it depends, depending on the size, the growth, and the business needs at any particular time.
Okay, thank you, Caine. Let's have a massive round of applause for Caine.